So graphs and gradients. So graphs is a very important concept to understand. Now graphs can be used in all subjects and they offer the same idea. Now graphs in general is a way of telling a story of how two variants basically change with each other, right? So in any graph there is a property that called the slope. Now slope is the change in y over the change in x. That gives you a certain value, okay, or it gives you a certain relationship between the variables that be drawn. So you should have known this from math that the gradient is the rise over the run, or the change in y over the change in x. You usually get coordinates. So for example, this is x1 and y1, okay? This is gonna be, for example, x2 and y2. For this point is x2 and y2. So it depends on which points they're gonna choose. Always gonna have some sort of coordinate, okay? Now, there are some relationships between the lines. This is a direct proportion because the line is a straight line and is passing through the origin. In B, this is a linear relationship. In C, this is what you call an inverse relationship that is represented by a straight line equation, which is y is equal to mx plus c. Okay? Now let's look at the types of gradients. Okay, we have a zero gradient. The line is not sloped. This gradient could be also called a slope. So a gradient or a slope. So this is not sloped or is not bending, nothing. Okay, so that's zero gradient. And then you've got the infinite gradient, means it's infinitely sloped. Okay, so we can give this a 0 and we can give this an I. Okay, now let's look at this one. So this is a constant positive gradient. So meaning the line is not changing, the line is straight. Is that bending? No. Is it curving? No. It's just a straight slope and it's going up, so it's a positive one. Okay, we can give it just a value of 1, for example. Type, or just give it 1, basically. It's just positive. This one is going down, so it's a negative value. Is the line changing or anything? No, it is constant, so also, but we could give it a -1 value. Okay, if you look at this one, this is what you call an increasing gradient. Why is it increasing? Because we can say at the start it was not bending, so it was 0, and then it started to go infinite, so we say I. So from 0 is going to infinite, so it's increasing. Okay, now in this one it was at infinite value and it's going to be at a 0 value. So I is going to 0, so this is why we go to say it's decreasing. If you look at this one, it was 0 and it now is going to be infinite, so we call it increasing. For this one, it was infinite and it's tending to be 0, so that's why we call it a decreasing graph. Now, why am I saying this? Because it's very important to what we're going to cover now. We're going to cover the distance time graph and the speed time graph. So bear with me. So in motion graphs, we have two things. We have the distance time graph and we have the velocity time graph. Okay, so in the distance time graph or the velocity time graph, there is the gradient. So gradient means delta y over delta x. We just said that. So for both sides, if you do this, so distance divided by time is what is the speed. So whenever you are describing in a distance time graph, you are describing the speed of an object. And for the velocity time graph, so delta y over delta x is basically the change in velocity over time, which is the acceleration. So whenever you are dealing with velocity time graphs, you are mostly talking about acceleration. So let's see the difference. Here you've got, for example, this is two sloped lines, A and B. Okay, so A and B are representing a constant speed because the line is both constant and it's positive, it's not changing. So it's constant, and what's the gradient is speed, so constant speed. So what's the difference between A and B is basically the slopeness of each line. So A is steeper than B, so that means object A has got a higher constant speed than B. Okay, so that's for that. And if you look at this one, you've got A and B, so both there are constant, and what's the gradient? acceleration. So constant acceleration for A and B. But what's the difference? A is steeper than B. That means that A has got a higher constant acceleration than B. Okay? Now for this case, ones that always get you guys confused. Uh, this is a zero slope. So it's zero slope. What is the slope? It is the speed. So zero speed. So the object is not moving. It is stationary. Okay? But if you look at this one, it's velocity time. So it is zero slope. So who is zero? The acceleration is zero. So that means the object is moving with constant speed. Why didn't I say it's at rest? Because this has got a value at some point. It could be 50, it could be 60, it could be 100. How come you could say it's not moving? You see? So that means acceleration is zero. So that means the object is moving with constant speed. Okay? Now, this one doesn't really come that much, but if in a distance time graph, a constant slope means it's constant speed, but it is going backwards. It's going what? It's going backwards. The negative here is for the distance, not for the speed. Now, this is as we said, a constant negative slope. So it is constant, so the negative of the acceleration is deceleration. So constant deceleration. Okay, now this one is an increasing slope, so it is increasing speed. For the other object, for the other side, it means increasing, but what is the slope? It is acceleration. Okay, this one, this was infinite, going to be zero, so decreasing speed. This was infinite, going to be zero, so decreasing acceleration. Okay, now in this case, this is decreasing speed, but in the opposite direction, right? It was infinite going to zero, so decreasing slope, which is the speed, which is in the opposite direction. Again, here it was infinite going to be zero. Okay, so it's decreasing, it is decreasing. And what is the idea of the slope? It's the acceleration, but it is in the negative part, so deceleration, so decreasing deceleration. Okay, here it was zero going to be infinite, so it is increasing speed in the opposite direction. And for this one, it was zero and is going to be infinite, so it is increasing deceleration because it's a negative side, so it's increasing deceleration. Okay, that's the idea for how to read slopes, which is very important. Okay, now let's continue with the ideas of velocity time graph. We've got something else, which is the area under the graph in a velocity time graph. Now let's look at this. Now the area in a velocity time graph usually represents the distance covered. Represents what? The distance covered. So for that case, so if we could read this graph, this is constant acceleration, constant speed, and then constant deceleration. Okay? You could use two things to calculate the distance. It's either you divide the shape into a triangle, a rectangle, two triangles. It depends on what the shape is, or you can use the area of trapezium. Okay, now I'm gonna use the area of trapezium for this at the start. Now this was base 1, and this is base 2, and this is the height. Okay, so base 1, the rule for trapezium, you should memorize this. So base 1 plus base 2 times 2 divided 2, sorry, multiplied by height. Some people like to write it as a plus b multiplied by half and then multiplied by h. I like to use this one. So base 1 is 9 plus base 2. You see base 2 started from this point to this point. So 7 minus 4, that is 3, divided by 2, multiplied by the height, which was 7. So that would be 9 plus 3, divided by 2, multiplied by 7. That would be 42 meters. Okay, that's one way of doing it. Okay, which is the most common one, basically. Okay, now also he could be asking, I'm gonna delete this. He could also ask you in a simpler way, to just calculate the distance covered while the object was moving with constant velocity. So therefore, you're gonna have to calculate only this area. So depending on the question, guys. So 7 minus 4, we said this is 3, multiplied by the height, which was 7. So this is gonna give you 21 meters, okay? Let's say he asked for the distance covered while the object was moving with constant acceleration. So therefore, you're gonna get this triangle, which is half times the base is 4 times the height, which is 7. So this is gonna be half times 4 is 2. That would be, again, that would be 14 meters covered when he was doing that. So basically, this is the main idea of graphs and how to calculate the distance. You have to analyze the question thoroughly and look at the axes, make sure you're doing the right calculations, make sure you are choosing the right points, and so on. Thank you for listening.